Now starting. All attendees are in listen-only mode.
Hi everyone, I'm Julia Hyder, Associate Editor with Modern Machine Shop Magazine, and I'm your moderator for today's webinar, which is sponsored by HiQA. Let's get started. Quality 4.0 is becoming today's reality. While automation moved to the manufacturing floor last century, automation of the basic quality process is lagging behind. Many manufacturers are still using pencils on paper to balloon their drawings and manually collect data for reporting. It can even take longer to produce documentation than it does to manufacture the part. These manual operations result in a higher than acceptable margin of error due to individual interpretations of drawings and transcription errors. In this webinar, HiQA will cover how automation can help you meet Quality 4.0 goals, the value of starting with a 2D drawing or 3D model, how to use a centralized database throughout the inspection process, and how to effectively manage communication with outside suppliers. Our presenter today is Sam Golan, co-founder and CEO of HiQA, a platform that helps shops automate their internal quality process and extend it to their supply chain partners. Sam has used his expertise in business development, product positioning, market strategy, and team building to guide HiQA from the entrepreneurial stage to industry presence. He has over 25 years of experience as an international executive and has founded, co-founded, and managed 5 different companies within the CAD CAM, PLM, CRM, knowledge management, and renewable energy fields. You can submit questions for Sam at any time during his presentation using the chat box, and we'll answer as many as we can at the end. Also, this webinar is being recorded, and you will receive a link to the recording via email. So with that, I'll turn it over to you, Sam.
Thank you, and thank you all for taking the time today. Yeah, automation, calibration, or collaboration, and trusted data from 2D, 3D files all the way to FAI will support a goal in reaching to a quality 4.0. But the question is where quality is today and what are the gaps quality needs to close getting there. So in the as a quality 4.0 is a subset of the Industrial Revolution, the 4 of them already. Quickly on the history, the first Industrial Revolution started at the mid-1800 to the early 1900 when steam served as a new source of power. The second revolution started early 1900 when electricity evolved and enabling machinery with the innovation of the production line. And then the third revolution from the early 1970s with computing, automation, and robotic replacing people mainly in a repeated job. And in the fourth revolution in the 21st century is actually the Internet of Things. We heard about it, it's IoT, with manufacturing techniques to enable system to share information, analyze it, and use it real time to guide us taking intelligent decision when we need it. Real quality actually started in the mid-1940 with the guy named Stanley Parker, who invented the true position, and then it follows the whole GD&T that we know what we do on a daily basis. And as quality 4.0 is a subset of each one of those industrial revolution, then the question is how much progress was done in our quality life in regards to automation, trusted data, and collaboration. Let's find out. Let's start by comparing quality to manufacturing industry we all know. Because this is what we do on a daily basis. We are inspecting part that being manufactured with all many others quality processes and of course requirements. So here's a question: how long it takes to, and how long it takes to create CNC process that knows also in toolpaths in the manufacturing terminology, cutting this part from start to finish. It takes about 90 minutes. This part designed and manufactured by CAD CAM software known as 3D System or previously Cimatron. Cimatron evolved or started its life in the mid 80s, but the CAD CAM started in the mid-70s, about 45 years ago, enabling seamless and automated design and manufacturing. Since then, CAD can become much more advanced, intuitive, faster, moving from wireframe technology to solid modular technology, enabling realistic design and manufacturing real-time with analysis, flow analysis, stress analysis, and many others. Let's see what progress quality did in the last 45 years. So creating ballooning in process, final inspection, reports, how long this going to take? 370 minutes, almost 4 times more than what we do in manufacturing industry. So the question is, why it takes so long to do it? And as you see on the print, we still, 80% of the industry is doing it manually. I'm not sure that this is take us very close to being 4.0, still doing GD&T manually, and there are much more gaps that probably we need to close. Now comes another question when we look into our quality industry. Okay, you can see here a long list of software packages that needs to serve us to complete a quality job from A to Z. Where all this data stored? Is this data available to us already analyzed real time when we need it? Let's take another quick example. There are thousands of inspection tools. There are thousands of many measurement tools, from manual to Bluetooth, wireless, CMM, vision, arm, laser, and the list is long and it is growing daily. The question is not just about measuring the part right, but where this data goes. Either it is written on a piece of paper or typed into Excel or clicked by Bluetooth device or by CMM. Here's another example. Let's talk about SPC, Statistical Process Control. It is an industrial standard for measuring and controlling quality for manufacturing process. Kind of quickly, SPC is a growing demand by the OEM from their supplier, and it is adding a significant burden and cost, of course, and require expertise and another software package solution among many others that are already part of the quality process. Maybe last example, APQP. Okay, let's talk about it. APQP consists of multiple packages and activities as manufacturing operation, process flow, PFMEA, control plan. Then you need to submit the package. And what software 99% of the industry are using? You probably know, Excel. It is Excel, but not just Excel. This is Excel on steroid. You can find proud people based on how many tabs they have on the APQP Excel file. No doubt these guys are extremely talented, professional, but what do you do with this Excel file when you have 20, 30, 40 tabs? Is it only to satisfy the OEM, the buyer? And what do you do in the next project? Well, best case scenario, you do copy paste, modify. Worst case scenario, you start from scratch. So it is not just about data. It is about quality and trusted data. It's about integrate, synchronize, and analyze data from multiple resources and tools, created valuable information. And let's distinguish between data and information. Information that you can use to make decision to improve not only the quality process, but the entire manufacturing process. This is where, by the way, we can start eliminating the notion that quality are no longer go, no-go department. We support prevention, and this is why we must target Industry 4.0 as a goal. One of our largest OEM business partners shared with us the following. I have a lot of data, but I do not have information. My data is stored all over the place in endless softwares, folders, as well as hard copies in boxes, reports, plans, in-process inspection, results, SPC data, engineering changes, you name it, I have it. But what conclusion I can get out of it? Nothing. My hope is that no customer will come and complain or auditing, so I will not need to spend 2 weeks to look for data all over the places. So quality, it is an integral part of manufacturing. And it seems that we are only chasing manufacturing by adding more and more inspection tools and be better and better as a go, no-go department is actually, we are considering as a big and expensive bottleneck. It is time to change, and actually we need to close 45 years gap as quickly as possible to be considered as quality 4.0. We need to stop chasing and actually start leading. Well, I think we talked enough about the pains and the challenges, and this is the time to see how can we reach the goal through automation, collaboration, and trusted data, and much more. So looking into what we do, we need to look into quality department and use it as a quality management system. And quality management system, or true quality management system, means we have all in one. We need to go to different application and try to synchronize between them manually by import, export. We need to have the data when we need it. So quickly about High QA. We are located in New Jersey, and actually not just in New Jersey. If I'll click here with your permission, if it will work, of course. Okay, and we are located also worldwide. And as you see, our distribution network and headquarters also in Europe, in Netherlands. Okay, and talking about customers, talking about industry served. We serve the aerospace, medical, automotive, defense, oil and gas, and many, many others. And our customers are representing a very, very large scope, for small job shop, 10, 20 people, all the way to enterprises like Lockheed Martin, Mercedes, Rolls-Royce, BAE, and many, many others. Well, to simplify quality processes, we can look into 3 components. There is the downstream preparation, when we take 2D or 3D model and we prepare it for data collection, which is the second portion that goes down to the shop floor, to the quality department, or outside to supplier or supply chain. And then after collecting data and analyzing it, then comes the reporting. So this is a simplified way to look into it, but let's take a deeper look when we talk about all-in-one system. All-in-one system actually serve, as I mentioned, OEM, job shop, and supply chain. In order to do this, then let's look into the infrastructure first. You have to have centralized database. Then another layer is API to support external system that you have in your organization, connecting to ERP, PLM, and many others through API. Then comes the layer of security. There is a security level on the user side, and there is an enterprise level for IT and access control. Then comes the layer of the source. What is our source data? And our source data is either 3D model or 2D drawing. Then comes the layer of, okay, let's start to do the downstream preparation. So either if you need to use APQP, it's integrated solution. If you don't, you can jump immediately to all those rich functionality and capabilities that enables you to do anything that you need to prepare whatever you require to do in the quality process. Then all this process assigned to data collection and requirements for the supply chain. And then of course come the data collection and the reporting. So this enables you to have all-in-one system in place that can take from the starting point, either 2D or 3D, all the way to reporting internally and externally. So if we take a little bit more look into it, and the 2D, here is a 2D print, and in one click, you ballooned it, you extracted GD&T, inspection plan, and many other components that does it here. And we will see it a little bit later through a real demonstration, of course. When we take the 3D, the same idea. We take 2D and 3D into Inspection Manager, but our model-based definition, as people used to call it, is highly sophisticated and intelligent. When we bring 3D into Inspection Manager, it comes with all the views, ballooned already and extracted. But any of you who is getting MBD today or plan to get it in the near future probably experienced or heard about the challenges. Here is an example. In many cases, MBD has limited dimension or critical dimension only, and it requires from suppliers much more work preparing MBD for real work on the shop floor and the quality department. It may not surprise you that many job shops who get 3D actually taking screenshots from the views or from the model, print it out, and add required data using pen or pencil. Here is an example here. If you look into the dimension 4, coming as part of the 3D, you see here the diameter 10.3 plus minus 0.3, 4 times. This is what engineer will send you. But we need to inspect all those 4 holes. They need to be identified for me, for the quality department, in order to report on them. So what we are doing, we convert 3D to 2D with all the required missing information because we understand this data. We understand what happened when we extract it. We understand when we have multipliers. So the system is much, much more intelligent. Just to try closing the loop of the process, then once you have all the preparation going downstream, data is collected from any inspection tool on the globe, either manual, automated CMM, VMM, and of course, we have shop floor data collection that works on a tablet or a PC, and all the results that will be entered in either by clicking on the keypad or using Bluetooth wireless goes directly, automatically, real-time into the database. Okay. Quickly on the data, then we have inspection data results directly to the inspection manager with automated alert, all type of reporting, and of course come very important integrated analytical and statistical process control that serve you into the entire process. And if we go deeper, we talked about security without diving into it too much. You can see all the layer of security by user and by organization. There is access control, working with large enterprise. As you see here on the lower left side, you can manage location, department, teams, user, and access by project parts. We don't need to go there too much in deeper ways. Let me kind of jump into quickly into Inspection Manager, because I would like to really show you how things are working. And I'm going to open a 2D print, okay, at this point from a file. And let me open not a complicated one, something that will make sense to you guys. And once we open it, and it doesn't matter what type of PDF or TIFF you have, we can handle all. And what happened now, when I'm going to click Auto Balloon, GD&T, and PMI, there are a lot of options what you can do. Of course, we are not going to training. And when I'm clicking create, then now the technology that created for many, many years dives kind of into the print, understand all the quality requirement and all the manufacturing requirement out of this 2D print. Automatically, we extract the data into a bill of characteristic, put it, of course, in a database. It's a database-driven application, as I mentioned multiple times. And then, of course, what happened in parallel, the print is also ballooned. And as you see on the print, probably 40 seconds or so, you got it here. Everything is ballooned, and all the bill of characteristic extracted automatically from this 2D print. Now, if we remember what happened in my previous slide, talking about or comparing between manufacturing and quality, how long it takes to create inspection plan from 2D print and how long it takes to create toolpath to cut apart, I think we are getting much closer, if not very close. But the 2D extraction, what we did here, definitely serve one of the parameters. We talked about automation, we talked about trusted data, and we talked about collaboration. So automation is here, and there are many examples in our application on automation. We'll touch them shortly. But this is what happened. Automation applied, but we also eliminate human interpretation about the requirement, which is another layer of having trusted data. Okay, so because it's a database-driven application, no data will get lost. It's stored in one location, and now at this point, actually when we have it here and it's trusted, then I can go concurrently and do multiple things. I can go and do final inspection. I can do in-process inspection. I can even start to collecting SPC data. Yes, even in this stage. If I'm going to talk about final inspection, and you can see here also clicking on dimension 6 here, you can see we are standing on surface profile 6.1, and then we can designate it, whatever it is, critical dimension. We can assign inspection tool, even its example not right, clicking save, and you can see that I'm assigning inspection tool and designator to my process. Clicking one click here, an inspection planner is ready because it's database driven. I don't need to copy paste. I don't need to type anything. There will be no error, time spending. In about 10 seconds, the inspection plan should be ready. Now, I want to make sure, here it is, everything is here ready. I want to make sure that we understand also the point that we are completely paperless system. You don't need to print anything, no Excel, no PDF, but because many of the organizations still heavily resides on paper, then I suggest we go first less paper and then paperless. Because we have this shop floor data collection, then all the data is automatically there. You create PDF from this part in one click, and we're all set to go. Now, talking about data collection, let's say this part is inspected by CMM. We can bring inspection results automatically from machine data, okay? And if I will simulate it, how it works, I can bring machine results. It's automatically, but I'm bringing it in 2 clicks. And you can see the inspection results came directly to the database, okay? With also color-coded the print based on the results. And you see the green supposed to be gray. Intolerance, gray is not inspected, red is failed. I'm clicking on the failed. Then I see it exactly what happened here. And now a very important part. We're talking about integrated solution. In many cases, if somebody needs to fill up NCR, then what we hear, oh, I'm going to my ERP system, I'm going to another system. Again, you can do it, of course, and you can continue to do it. But if you see here NCR is integrated. You just click on it, on the add, and your NCR is ready to fly. And you can fill up and manage the whole NCR process. And of course, you can export it out. And of course, you can carry NCR reports, but it's all integrated here. That's what we are talking about. Inspection results coming automatically. If I will open the part again, not the results. And of course, we never lose something. It's all stored in a database. Now I'm taking you quickly on another avenue, if you will. And this is the part, of course, we made, okay? And I can take it here and even start with collecting CMM results in this stage. Because usually CMM, it's done when you have results. But CMM become kind of a easy way to do it now. As you see here, we have we have SPC here and AQL setting. And if I need to collect data from, let's say, dimension 15.3, I can collect by clicking SPC, setting up CPK, PPK, whatever I have, collect data, click OK. Let's do another one here. SPC setting, same idea. So now my SPC process is actually completed by me as a user. If I'm going to click SPC here on this tab, right, you can see here the two features I selected. And when I'm going to get inspection results, the SPC will be filled up here. I may take you a little bit kind of away so you understand what this system can do when we talk about quality management system. If I'm going to click on jobs here, okay, and I'll delete this one so it will not bother us. And I'm going to add another job. As a quality management system, here is my new job, okay? And my new job has a job number, and job number will come from ERP system. Again, using API, as you remember, if the part of the slides talking about all-in-one, we have an API, so you can connect automatically via API to ERP system and get the job number there automatically. Also the quantity, now it's an active job, and we have to deliver it on, let's say, June 30th, okay? And we have a lot number, and it's not planning, it's active. And there is the due date with, you remember, the same idea. Also, we can break it. And now, if I will use my default, okay, and inspection level 2, then by clicking OK, the system will let me exactly what I need to do and how many samples I need. And that's how system going to work, including managing SPC data. Another look into this quality management system, going back into the drawing, okay? I mentioned in-process inspection. In many cases, we handle final inspection and in-process inspection in done in multiple ways. But when we talk about quality management system, then if I will go here to the right side and click on manufacturing operation. When I'm clicking on manufacturing operation, then the system will turn the drawing into attention mode and said, okay, this is your finished part. How are you going to go to this part? You have a block of material, aluminum in this case. How many operation, how many settings you're going to do, and what you are going to inspect in each operation. So here is an example. Let's say I'm going to cut this block of aluminum. I'm going to do roughing, and then I'll do semi-finish, and then drilling. So let me add operation and see how it works. So for roughing, I'm going to select the width, okay, and this one as well, and then the height. I think this one, number 4, and I'm going to add operation. So here is operation 1 added. And if I need another operation, I'm just arbitrarily playing. Here's another operation. So now I have 2 operations, and I can go on and on. There is no limit on how many operations you can add. Now at this point, when I'm clicking on the pencil, okay, now I can add data for each operation. I can call it by its real name. I can set up what machine is going to make this part. And remember, we are talking about integrated solution. We are talking about working with manufacturing. So now we can collaborate with manufacturing and say, okay, how this part going to be made? Usually, you know, we meet the manufacturing on the CMM, and in many cases, it's too late. Let's talk about it now. Let's give it a name, what we are going to do with it, machining. What instruction we need to add for this operation. We click OK, and then we have operation 1 set up in the system, but not finished. I can do it with op 2, 3, 4. But let's see what we can do with operation. So here I'm having roughing. And here is my system. Pretty intelligent. Now you see what happened. The roughing balloons only highlighted now on the print. And I can now go and create PDF if I need it on paper for operation 1 for the roughing, as you see here. And I can go and create inspection plan for the roughing, okay? But the inspection plan is not ready yet because all the nominal and tolerances here belongs to the finished part. So the system enables me to do update on the nominals. Very simply, you can go here, you change the nominal. Let's change it, for instance. Let's add value by percentage. I'm adding 15% to the nominal. Let's say 10% to the upper tolerance. You probably got the idea. And 10% to the lower tolerance. And by the way, we talk about SPC. We also enable SPC for in-process, which we believe it's not less important and even more important than SPC to the final part, because when you do SPC for the final part, in many cases, it's too late. Why won't we run SPC, create sampling, so we can avoid problem while we are making the part and do a lot of prevention. So when I'm creating this process, and now the nominal and tolerance are ready, then I can go and create inspection plan for operation 1, and the system know exactly where I am. I'm in roughing. So I'm creating report for the roughing. Again, takes seconds, and I'm repeating myself. You don't need to create this Excel. It's all paperless, but now all I need to get is actual from my shop floor on this operation, okay? So kind of understanding what we are doing as an example with a concurrent activities. So we can go inspection, final inspection, we can go in process inspection, and we can do and start to collect even SPC now. Other things that we may want to look into, it is as an integrated system, we are managing gauges and inspection tool, calibration, expiration date, and we believe that this is very critical as part of the integrated system. And we need to cover it, and I'll try to cover it very quickly. And you see what happened here. It's integrated with our solution. The way we take it, for instance, if I'll jump into setting, you can see here in the default setting that, for instance, the system, as you see here, allow expire tool, will not enable any tools that is out of calibration get data into it. So you're going to pick out of calibration inspection tool, the system will say, thank you, no. And you see here, for example, those expired inspection tool, and the system can enables you to get alert ahead of time, and it give you alert like 40 days, 50 days, 60 days, whatever it is, setting up or calibrate your tool before it's going out of calibration. Another way, when we talk about automation, there is a default tool category. So every organization can set up its tool category based on their process. I'm just playing here. And then the system, when it extracts data from a 2D print, it will automatically assign this tool category in place without having anybody to guess what tool I'm going to use, and so on and so forth. Okay. Now, quickly on the data collection, which I would like also to share with you, talking about a comprehensive quality management system. If I'll go here, this is our shop floor data collection, okay? And you see here IQA collection terminal that works on a PC or a tablet. If I will log in, okay, to the system, and I need to log in with my name as password, or if you have badge, guys, you can scan your badge and log in automatically. So I'm logging in, and there's a lot of option to do here. One of the things that you can have is we are managing gauges and inspection tools, and in many, manufacturing companies, you can see people, running over the shop floor looking for inspection tools. You can avoid it. When you click gauge, everybody can see who is using what, okay, and you can see where the tools are, and you can get there, or you can get it without, spending mileage to look for tools. Another way to collect data, which is important, here is a gallery search as an example, and you can browse the process. You can select the lot, and here is my lot. It shows me in a very nice dashboard what is the status of my lot. Total samples, inspected sample, pass sample, fail, non-conformance. If I'm going to click on the lot, now I see the 6 pieces I have to do. And I can click on any of the lot here, and I can see the status of the part, how many feature inspected, pass, fail, non-conformance. When I'm double click on it, now I'm in the part. When I'm on the shop floor, first operation, second operation, whatever I need to do, now for me, it's extremely easy as an operator to enter data, either Bluetooth wireless tool, or if you look into dimension 1, okay, talking about 003, I'm just clicking 003, click accept, okay, it turned green, but this results, it's not here, it's in the database already. 2.1, it's 017, 057, click accept, results in the database. Let's fail one. This is a gauge or thread actually. I'm going to fail this guy. I'm clicking accept, and the system tells me it's an option. This measurement result is out of tolerance, failed. Would you like to measure it again? Let's say I don't. Keep it failed. I'm clicking keep it failed. You remember NCR. Here is NCR here. So it's all, of course, connected. So I can fill up NCR. I can attach it if there are existing NCR, and I can add new one, and you can fill NCR on the fly. Of course, as long as you have permission, because the system, as you remember, manage user and credential. Not everybody is going to do whatever he wants. It's based on his profile and whatever credential he has. So data collection has a lot of capabilities. I'll show you a little bit later. We left with another 6 or so minutes how it works when we talk about supply chain. So going back to our system, okay, and opening the part again, just to give you an idea, when we talk about trusted data, we talked about automation, and now we would like to talk a little bit about collaboration. So collaboration with whom? Definitely collaboration with all my processes and my team member, but there is very important collaboration with suppliers. It might be a supplier who makes the entire part, but it can be a supplier for a small job shop who is doing plating or heat treatment or whatever you do outside. You can manage them very well. As you see here, there is a supplier exchange tab. And in the supplier exchange, you can manage all your suppliers. And again, behind this screen, there is a lot of automation and data. But if I'm going here to KG as my supplier, and you can find all the information about my supplier or your supplier, okay, then if you need to send a part, click on sending part. You can pick the supplier, you can put the subject, you pick the feature or the part that you need to send, put send part, and he is going to get it, and he will open it the same way that you see it on your screen. So it's not just taking 2D or 3D, it's also what you do it downstream preparation, how you collect data from different inspection tools, how you analyze data real time, and everything here it's real time because it's database driven application. And maybe to close this loop when we talk about collaboration, let me quickly jump back to my presentation. And I would like to talk quickly here on the supply chain, or if you will, it's HiQA 360. You can find more information in our website. But the idea is that now you have kind of a concept on quality management system. This is how you prepare your package for downstream. From a 2D print or 3D model, you can create it here. You can use APQP if you have, or you can skip it. And then all this functionality that you kind of started to look into it, created the package for downstream. Now your supplier outside or your manufacturing department or quality department on the shop floor are like the same. Supplier is like an extended arm of your manufacturing or quality department. Now, when you send them through a supplier exchange, this is what they are getting, and this is what they can do using our shop floor data collection, again, on a PC or a tablet. And you see exactly what I showed you there. So this is what supplier will get. He will collect data. You can share with him instruction, even how to collect specific data on a specific feature or a specific tool. We also enables to manage supplier inspection tool. So you're going to be sure that your part is inspected with calibrated tool. Supplier can collect data the same way we collect data. And even supplier has no really idea or clue how SPC works. You can set up SPC in your downstream preparation, and supplier can see the behavior of an inspector part based on your SPC. He doesn't need to make it or do it, but we would like prevention. So we would like him to see what we expect to get when we inspect part. So all this information gathered and create a collaboration between suppliers and buyers, or OEM, if you will. And then, of course, the OEM or the buyers can have this data real time. And just think about the idea that the package that you prepare is going to eliminate interpretation also from your supplier. Because today you send them naked print and they do the ballooning. If you send the same part to 3 suppliers and each one of them will do the balloon print, you're going to get 3, call it different part, maybe intolerance, maybe not, but different reports because everyone interpreted differently, ballooned differently. So actually, the whole idea when you do downstream preparation with inspection manager, then you create a standard language between everybody from the starting point. So I tried in 45 minutes, and I hope I did it successfully, kind of share with you the idea, and let's go back to quality 4.0, what actually we need to do and what gaps we need to close to get to quality 4.0, which is a automation, trusted information, and collaboration. And I'm not sure that we closed the gap that opened in the last 45 years for the quality department, but we definitely much closer to quality 4.0 with all this automation, collaboration, eliminate interpretation, and trusted data. So with that, I really would like to thank you for taking the time, and I would like to leave time for Q&A if you have any. So I will turn it back to our colleague.
Hey, Sam. It looks like we have a couple questions already, but there's still time for you to submit one. You can just type it into the question pane at the right of the screen, and we'll do our best to get to it. All right. So first question, can we integrate other SPC software like QDOS with HiQA?
Absolutely, yes. We export data in all type, shape, and form, like XML or CSV or whatever, and we are already integrating or integrated with another SPC package. Well, I can mention PCCal or QCCalc and Minitab. It can be done via XML or CSV or using API if the other software has API. So the answer is absolutely yes.
All right. Does Inspection Manager comply to AS 9100D requirements?
That is correct.
Okay. For manufacturing operations, if roughing is entered, dimension will not match final print requirement. Would manual override of dimensional requirement be needed?
I didn't hear well the question. Can you repeat, please?
Yeah. For manufacturing operations, if roughing is entered, dimension will not match final print requirement. Would a manual override of dimensional requirement be needed?
Well, the question is, what is the process? Because I don't understand what is the manual override. Do we allow manual override on the results? You can do it if you have permission to do it. So I'm not clear about the question. I don't know if this person can more clarify what he means by this question. I will be very glad to answer.
I think they're asking about if you were to enter the roughing in the middle of the process, if that would affect the final outcome.
If
you said you answered the question.
Say it again, sorry?
You said you answered the question. We're good.
Okay.
All right, next question. Can we import the digital dimension measurements into HiQA?
Yes, we do. Yes, we do.
I saw basic dimensions were ballooned with and listed with a plus or minus 99.00. How are basics managed as they're generally not measured and naturally are theoretically exact, no tolerance?
Okay, through kind of showing quickly what the question is and what I would like to kind of share in more visual way. And the gentleman is right. And what we have here, we have a decimal table, and I picked the default because I played with it. And I decided that my default will be, as you see here, 99, whatever the case. So anybody can build his decimal table based on the dimension or the default tolerances that he has here, okay? And you pick them up here, whatever you have, and the system will automatically assign those tolerances if there is no GD&T on the feature that we balloon. If there is GD&T, we will not assign. So yes, you can, and that's the way to do it. We handle also range table without diving into it. As you see here, with all the ISOs. So yes, you can do it in a better way that I did, 9999, that's what I did as a default.
All right, how do you show the dimension on the 3D model? Is it possible with an STP or IGS model?
Okay, the idea behind 3D model And I think we have a couple of minutes, so I can maybe open it. I will give you the concept about 3D model from another remote server, if you will, quickly here. And if I will open a CAD file, and we support all CAD files. So I'm opening now, I think it's Creo file. Okay. So we bring in the whole 3D with all the information that it's on the 3D. Okay. But we bring in also all the views associated with the 3D. Okay. If I'll click here, okay, and you can see here the 3D rotating. But the problem when you bring 3D model, okay, it can be CATIA, ProE, Siemens, whatever, okay, then there is a lot of data that it is not relevant for quality to be here. And actually what we enables our user is to edit the 3D model. You see here there is disable. If I will turn the disable to enable, okay, now you see a flag note, whatever the case is, that I may not need it. Okay, so you can change the status. I'm deleting it from the view. Okay, so you can edit your 3D model before you taking in, and this is what I'm doing now. If I am doing now, after I edit the 3D model, whatever views I have, I'm extracting the data from a 3D, and you will see it on a second, with all the views. And now you're going to see, as I did, okay, now you see here, all the bill of characteristic become a pure 2D. And now you remember this 4 times 3.0, 10.3 plus minus 3, okay, that you can multiply. So all the 3D, after you edit it, you prepare it, you clean what you don't need, now it becomes a completely 3D, sorry, completely 2D. Now on the 2D, you can add a lot of information, whatever you need, because there is not enough, let me close it, guys. There is not enough information on a 2D in order to edit. So in some cases, okay, you can add notes, okay? And if I would like to add notes, you add the notes here, okay? So there is a lot of option to handle it, but the idea is you bring 3D, you edit it, you extract it, and it becomes 2D. So now you can handle 2D because that's the way you communicate with shop floor. I mean, I don't think that anybody will take full-blown 3D model with all the information or definitely missing information, give it to a guy on the shop floor, he can make the part. I think it's a little bit theory. So I hope I addressed this question.
Okay, how accurate is the drawing and ballooning recognition? Does it have to be drawn for a certain specification such as ASME Y14.5?
No, it's accurate. Again, if you are having a very, call it manual handmade print, you see here we lock the print because I created inspection plan, so let me unlock it. But it doesn't matter, whatever you will do will recognize. Now if the print is, you know, very awkward and manually done from the 60s, and you see I deleted dimension and you have 400 balloons on the print, you would like to find a missing balloon, here is one. And again, I'm fixing it manually because we live in our life, okay? So I can fix it manually. Sorry, not this way that I plan to fix. Let me just delete it, okay? Here is deleted. So I can add this balloon and move it away. There's a lot of stuff you can do here. We don't need to go into training, but I'm capturing this balloon, okay? And now it's added to my inspection below. It's 25. And then you can go and you see it's linear in the database. But if it's not right because the print is from the 60s, then change it. You can call it diameter, you can change parameters, you click save. Now you see I have diameter in the database. And you can, of course, go and renumber it as you need, okay? And you see it's here already. So again, there is no rules. We can identify or recognize all type of dimension, all kind of ISOs or standard. But the key is when we go to a very old print, even old print, you can finish here. You may invest another minute or two. But the idea, once it's in the database, it is trusted. And that's the point I'm trying to make.
All right, what extension, CSV/XML, is used to import CMM data?
You can set it up. You can set it up. We have a very, I would call it sophisticated data collection from any CMM, but the decimal point is a setup that can be done very easily.
How well does it work with bigger or more complex drawings?
As it works on this one. I'm not sure I have an example here. Definitely not one that I can share, but not an issue. We have worked not just with complicated drawing, but I'm trying to see, now this is easy drawing. There are many that, I mean, this one, or it's not even about the drawing. Here is one I cannot share with you guys, but it's working, okay? And we have customers that not just having drawing with 300 or 400 dimension on a print, they have multi-pages. And just to give you an idea here, when you start to do ballooning, you have option to do one page, multi-pages, you can select pages, you can avoid basic or reference dimension. There's a lot of options. So there is no limit on, there is no complicated prints for us. By the way, I think even 20-meter prints, and we have big project that done by Subaru on a 777 project 2-3 years ago, and their prints are, I'm using meter, I didn't convert it, but they are using 20-25 meter long drawing, and it took them almost 2.5 weeks to balloon every feature, actually fastener on the print, and now it takes them 3 hours. So.
All right, we have someone asking if they can adjust the default tolerance table on a customer-to-customer basis.
Yes, they can.
All right, and how can we use the same drawing for different projects?
Just to give him a different job number like I did here. Actually, this question is a good one because when we talk about database driven, let me give you an example. I didn't do everything. Maybe you have another 1 or 2 minutes, but if I'm here, okay, even this print, if I will go here and I will extract data from title block, you see the database fields, part of them are here. And if I'm capturing the part name that goes now into the database, you see here on the right side, the part revision going into the database, even part material goes into the database, as you see here. Again, you can print it, but I'm lazy to. So I have those, and now it's in the database. Now I'm getting this part 2 years from now. I can, without engineering change and no revision change. So I'm getting this part, I'm pulling it from the database in a heartbeat, give it another job number, and whatever I did, although it takes minutes, just, it's ready. You don't need to do it again. You can give it a new job number, like here, as you saw what I did, and that's it.
All right, we have one more quick question. This is from our current HiQA user asking if it automatically updates when you update the product.
It was very high background noise. Can you repeat, please?
I apologize. They were just asking if HiQA automatically updates the product.
Automatically update the?
Yes, if high QA automatically updates or if that has to happen by another process.
I didn't understand update what?
High QA. If you update high QA automatically for the users.
Update, you mean new version, update revision?
Yeah.
Oh yeah, yeah. The system update, well, there are multiple ways to do it. First of all, talking about user, all the user connected always to the support center. When they click here, they are connected to the support center. They can open ticket and immediately somebody is talking to them, okay? And then for information, check for an update. You can see below here, checking for update. This time, no software update are available. But the system will update automatically. Again, the user needs to confirm it, and then the system will update. It takes seconds to update the software. But very more importantly, is that no user, no company, no organization from update to update will lose 1% or fraction of a percent of their data, which is very important. Now, when we talk about organization, when we talk about large organization, because we are database-driven application, let's say you have a centralized database with 200 users, the update is installed by the IT in many cases on the high QA server or database, and then the automation, the revision update will propagate it and automatically update all the user at once. So there's a lot of IT tools in our system to support it.
All right, that concludes today's presentation. I want to thank Sam and High QA for making this webinar possible, and thank you to everybody for listening in. You should receive an email with a link to the recording within the next few days. Thank you for your time and enjoy the rest of your day.
Thank you.